Predicate logic. In propositional logic statements, which are always like fixed, is if something a question will be there, like if 5 is a prime number, then there will be two options only, either it will be true or it will be false. But in predict logic, the statement contain variables x is greater than 5, x is prime number. Okay, so x is greater than 5, x is prime number. They are not proposition until we assign a value to it in the x, right? So they could be anything, right? They could be anything. Until we assign the value in x, then they become propositions. So such statements are called open statement and or predicts. Examples: p x equal to x is even. Okay, if x equal to 4 and p 4 is true, right? Because this is even. If x is equal to 5, then p 5 is false because this is odd, right? So there are two things: quantifiers, okay, which is this opposite or reversely symbol, and this is opposite e symbol, which is for existential, or this is for universal. So let's talk about this. So what's quantifier do is quantifier tells us how many values of x make the state true. So because x is a large set of numbers, it would be infinite. So how many one will be true statements, that will be tell by this with the help of quantifier and these two symbols. So let's start with the first symbol, which is universal quantifier. It's opposite a symbol, this symbol opposite a, universal symbol. X p x means for all x, whatever the x 1 2 3 for all x, px is true. Okay, so px is true. So example, so whatever the x there will be in universal, everything needs to be true, right? So this universal x plus 0 equal to x is true, but this universal x is even is false. Okay, let's see the existential. So here, existential quantifier e with the sign symbol opposite e symbol, this existential symbol x px means 1 must be true in px. Okay, so there exists at least one x such that px is true. So in a set there should be one x which will be true, there will be true. Okay, might be rest will be false. So example, existential x is even, which is true, but x square equal to 3, x square equal to 3, no, right? So in integer it will be false. So one example to understand is to be sure, I really don't understand this examples and this example, but with this I somewhat get this universal or the existential thing. So let's see this. Px, x is a prime number, okay, prime number which is divisible by itself and by 1. So let's see. So universal sign x, px, every prime number is prime number. Does every prime number is prime number? No. There are some number which is prime number, okay, and some are not, so it will be false, because every number is not prime number and universal needs everything to be true, so this is false. Second example is for existential to understand ex px. So there exists a prime number, yes, in the integer line, in the number, whole number, whatever you say, the number, there exists a prime number, right? 9 is a prime number, okay, so true. And there's some work to do. If it's optional, you can do it or you can ignore it, but let's see. So universal sign x square, his this sign is greater than or equal to, means it does x square is greater than 0, or it's equal, or this existential x2 is equal to 2 in integer, right? This thing here is false, right? False, but here it would be true. And in existential x is divisible by 7, there would be, because this is existential, there would be one number which will be divisible by 7, right? So it will also true. And that's all for this video. And if you didn't understand, it's okay, but the main thing, you keep doing it until you get the things to understand it, so it's fine. Let's continue with the next video when I will upload.